Hi everyone. We're back inside our initial setup scene because what we're going to do now is just start creating the main effect for this week, which is going to be the dragonfire. I've made a few small changes. I've just updated this bridge with our new bridge model. And I've also brought in our sky and the sun from the environment section. Now the first thing I want to do is let's just save as. And let's create a new folder and call it shot1. And let's call this file also like shot01. And let's call it dragonfire and version 1. So now that we're inside this new file, we can actually just delete everything that we don't need. So let's just delete all these cameras and just leave the camera for the shot. Another thing we can do is let's just change the frame range. Because if we look at the camera, it's from frame 1001 up to 1133. So let's just adjust this like that and hit apply. And before we start creating the effects, I usually prefer to set up the collisions. So let's start by doing that. Let me just arrange things a bit. But yeah, let's create a new geo. And let's call it collision and terrain. And let's bring in the terrain we have. We'll drop down an object merge. And over in the terrain, let's bring in the null here and into this object. Now, when we have this kind of terrain, we don't want to use all of it as a collision object because we just don't need it. We're gonna need this section here around the dragon where we're gonna have the fire. And having all of this terrain being calculated as collision object will just slow down things too much. And it's just really unoptimized. So let's drop down our delete. And I actually want to use delete by bounding volume. And let's just give it something quite big for start. And also give it some height. So this is not bad. Maybe you can try 150. Let's go for 160. And this kind of covers all the area that we need. And let's just select delete non-selected. Next, what I want to do is let's just drop down an extrude volume. And what this does is it just, you can see, it extrudes everything down and gives us kind of a closed geometry. And just drop down a normal to fix the viewport. And now we can just drop down a collision source. and also drop down 2 nulls. So we'll call this one geo, and we'll call this one VDB. Another thing I like to do is just take a look at your VDB for this collision geometry. And just take a look that everything is working properly. You did see it takes quite a while to just calculate it. We actually don't need all this detail. So let's just go over here to volume and make the voxel size a bit bigger. So maybe 0.2. And yeah, I think this will work fine for this section. So that's it for the terrain. Let's also give it like a green color. And let's drop down a new geometry. Let's call this collision dragon. And the same as before, let's object merge the dragon. And yeah, like before, I don't want a collision object for the whole dragon. We just need a collision object for the head that's breathing fire. So let's just select this. As you can see, it's packed. So let's just convert it to polys. And now I just want to select this head. So let's just do something like this. Just make sure to select everything. And also make sure not to select anything else. This should work. Let's press delete and delete non-selected. And let's just close this opening here. So we'll use a polyfill. And let's just use triangles for this. And let's drop down a collision source. And again, we can drop down 2 nulls. Let's call this one geo head 01. I'll call this one VDB head 01. Yeah, and this seems fine. We can actually give it some more resolution. It's probably not necessary, but why not? It's quite fast to calculate. And let's also give it a green color for collisions. And we can turn these off. Now that we have the collisions ready, just before we start creating the dragonfire, I wanted to bring up these 2 references and kind of just take some points and see what we want to create and see what kind of elements we want to also incorporate into our scene. So if we look at this reference first, There's a few things I really liked, and first of all, you can just see the way it looks. We get this kind of really thin stream of fire moving really fast, so it's almost like in a straight line. And when it hits the floor and the collision object, it kind of moves almost like a flip simulation. It kind of flows along the ground, and only then it kind of billows up and create the fireballs. We can do this maybe using a flip simulation or just regular particles. And yeah, another thing I really liked is just this coloring. We get this blue flame over here, and only then it gradually goes into the yellows and oranges. So that's definitely something I also want to incorporate into our sim. And also the general, you see the general look of the frame. We get these really wide glows. We get the fire is quite overexposed. And we also get these kind of embers and lingering smoke being lit up. And if we look at this reference, the main thing I wanted to get from this reference is just the speed of the initial burst. So if I'll just play it, you can just see how fast it moves. It kind of really shoots it out, and it gives a really powerful feeling to it. And another thing we can look here is once it's actually hitting something, you can see it's shooting out really fast, and then it kind of stops and creates this fireball. So that's another behavior that I would like to achieve. And just a small note for next week, if you look at the exposure right now, everything is overexposed with the fire. And as the fire lingers in the frame, you can see the camera kind of getting darker. Everything else is getting dark, and then we actually see the flames inside, like all the detail. So that's another nice touch to add to our shot. So let's go back inside Houdini and continue and actually start creating the dragonfire. Let's start creating the effect. Let's drop down a new geo. We'll call this effects dragonfire, and we'll give it 0, 1 for now, because I do know that we have 3 heads, and later on what we're going to do is just duplicate this setup and apply it to the 2 other heads as well. So let's go inside here and drop down an object merge, and let's just bring in the dragon. So if I'll just draw here for a second, what I want to do is we need an emitter over here inside the mouth, and we also need a vector pointing outwards, and we need them also to be moving together with the animation, so it will all be facing the right direction when the dragon moves. And to do this, we can actually just select 1 point here and 1 point here, and then calculate the centroid position. And this will give us a floating point inside the mouth. And we can also do the same thing for like the end of the mouth. And once we have these 2 points, we can just calculate the vector between them. So we'll just subtract this position from this position, and we'll get this vector pointing out. So let's start doing this. First of all, let's just convert this dragon 2 polygons. And let's select our points here. So for inside the mouth, let's just select maybe this one here. And this one over here. And let's just press delete and select delete non-selected. And now that we have these 2 points, let's just use extract centroid. And this will give us 1 point in the center. Just delete this name attribute. And you see, we get this point. And also when the dragon moves, it's moving with it. So let's do the same thing for the tip of the mouth. Let's just go to this blast and select 2 different points. So let's select this one here and this one here and press enter. And now the extract centroid gives us this point here. So now that we have these 2 points, we can actually just calculate the vector between them. So let's do this using a wrangle. And we'll connect the first point here and the second point to the second input. And we also want this vector to be velocity. So let's type v at v. And let's type point. Press 1. 1 meaning this input. And we want p for the position at ptnum. And we want to subtract it from our current position. So we'll type at p. And if we look over here, we have this new attribute for v. And when we have the animation moving, it's still pointing in the right direction. Now let's just copy a sphere here. So let's drop down a sphere. And I want it to be polygon. And let's just use copy to points. And you see once the sphere moves here, it actually picks up the velocity. And let's just give it a higher frequency. And let's just lower the scale quite a bit. Remember the references, the stream it should be coming out in a very thin line. And this can work well for that. Another thing I want to do is let's just add another wrangle. And what I want to do now is just add some controls. Just something to control the velocity. So we can just do v at v. And let's do multiplied equal. And we'll create this channel float. And we'll call it vel mult. So it will be a velocity multiplier. Let's create this parameter. And you can actually see it controls the velocity. And we want it to be quite strong, so let's just give it a value of 15 for now. And we can change it later on. And what I want to also add is another wrangle, and this one will be a control just for the direction. I want to be able to kind of control the up and down if we need to make some tweaks for the particles later on. So for this, we can use a vector. We'll call it dir for direction. And let's just set, and we'll use 0 for the x. We'll use a channel float for the y, which will be the up and down. So let's just call it up. And we'll use 0 for the z. And we want to apply it to our velocity. So we'll do v at v plus equals dir. And let's just create this. And you see what we have now is we have this control that moves everything up and down. So we'll just leave it at 1 for now. And we can drop down the Botnet. Before we start on the Botnet, you can see it just calculating all these frames. Let's just have a quick look and decide when we want to start emitting the particles. So maybe frame 1068. Let's just go over here and set the start frame. Now another thing we can do is, you see when we go inside the Botnet, we can't see what's happening outside. And it's kind of helpful to see everything in context. Let's just pin the view over here. And now we can go inside and start working on it. Now, the first thing I want to do is let's just go over here to the source and adjust the life of the particles. We want it to be something quite small. So let's use maybe 0.1. And let's give just a tiny variance as well. And we also want the dragon to stop breathing fire eventually when he finishes his animation. So maybe on this frame. So let's just go over here on the constant activation and type $FF is smaller than 1106. And you see now he stops breathing the fire. I also want to go over here and just I basically want the particles to go faster. So maybe 3. Maybe a bit more. Yeah, because I want the particles to actually interact with the ground as well. So this looks good. But you can see the first frame is kind of too strong. So we can actually just keyframe it. So let's give it one keyframe at frame 1070. And on the first frame, let's just take it down to maybe 3.5. This way we get this kind of a shorter burst. And it just ramps up a bit as he starts breathing the fire. Now, another thing you can see here, we get this kind of stepping. So let's just go out and give it a few more substeps. We can try it with 2. See, this is better, but still we get these stepping issues. Let's just give it 4 substeps. It's quite a simple simulation anyway. And that fixes it. Now, another thing I wanted to incorporate from the reference is just adding some gravity, so we get kind of an arcing shape. So let's just add a pop force. And let's give it something quite large, like -50. Because everything is moving so fast, we probably won't even see it. But I do think it kind of gives us a slight arcing shape here. Now what I want to do is let's just bring in the collisions, because as you can see it's going through the ground. So let's drop down a static object. And over here, let's just go to collisions terrain. Over here, we'll select the geo. For the object path, let's just select collision terrain. And over on the collisions tab, we just need to go and change the mode to volume sample. And then in the proxy volume, we just select the VDB. And let's just merge it together. Now let's just remove this. We don't need it to display. Another thing that's happening here, it's just importing the collision object as well. So let's just do here pop object. And this way it only imports the particles. Like it will import this pop object. And you can see we actually getting some collisions here. I want them to stay quite close to the ground and not kind of spray upwards like this. So what we can do here is let's just add a pop drag on these particles. So to do this, we need to go to the pop solver, and if we'll go to collision behavior, we can just create a group for the hit particles. So we'll just call this hit. And over here, we can just add a pop drag. And then just tell it to use the hit group. So any particle that hits the ground, it goes into this hit group, and then we apply this pop drag onto it. So let's just use 0.4 for now. Let's just try something really big just to see that it's working. Can definitely see everything is sticking to the ground. Let's just use 0.4 for now. And just see if it's too much, we can always increase this later on. Now that we have this particle system working, you can see it's starting at the correct time. It's actually interacting with the ground, and it stops according to the animation. What I want to do now is just apply some noises and kind of create a more interesting source for the Pyro sim. You can try and do it inside the Botnet, but it's much easier to keep it simple over here and then apply all these kind of noises afterwards. So let's just start by dropping down a trail. And let's just give it a length of 4 and lower the increment to 0.5. And this just gives us some more points, and it makes it a bit wider as well. Now another small thing, you can see it takes everything a bit down, so if we just use a transform, we can just bring it back to the center. So maybe 0.2. And now I just want to create lines from these points. So let's drop down and add, and we'll use the particle IDs to connect these points. So let's go to polygon by group, and if you go to by attribute, you can just use the particle ID, and then we get these lines connecting the points. Let's drop down a resample and resample these lines. And you can see we're just getting much more points now. And I also want to create a curve view attribute. This is an attribute that gives you a value from the start of the line to the end of it. So we have 0 over here, and by the end it will be 1. So we can kind of use it to control some of the noises. And now we can just drop down a point VOP. And inside here we'll just, let's call it just add noise. And let's just go inside here and start setting up the noise that we want to use. Let's drop an Antiallies noise. And we can just connect it to the position with an add. And let's just make the amplitude a bit higher. And you can see it acting a bit strange, so we need to change it to be a 3D noise, and this gives us the correct behavior. Now what I want to do, I don't want the noise to be applied near the mouth. If we remember the reference, we want it to be kind of a straight stream over here. So what we can do is we can use the age and the life. And when the particle is birthed, the noise will be lower. And when it dies, it will be the strongest. So to do this, we just drop down a divide. And if we divide the age by the life, we get the normalized age. And now we can just plug this into our amplitude. You can actually see it's straight over here. And as the age goes up, the noise becomes stronger. Now let's drop down a control for this. So we'll just drop down a multiply and drop down a parameter for this multiplier. So let's call it mult amp. And if we go outside here, we can just give it a higher number. And you can see the way it's not affecting the positions over here. And over here it's much stronger. So let's just use 8 for now. And yeah, let's add another control for this. We can actually just bring in the curve view that we created before. So if we use a bind and choose a curve view, we get this value from 0 to 1, depending on the length of the line. And then we can just drop down a multiply and just multiply the noise by this value as well. And just so we have control over it, we can just use a ramp. And let's just use a spline ramp. And we'll call it ramp curve view. So you see, if we play around with this ramp, we can actually kind of control the shape of it. But let's just set it like this for now. And I just wanted to make these values available outside. So let's just right click and create input parameters. So let's just check what kind of a frequency will work. I think 1 was actually quite good. Let's use 1.2. And we can also add some animation to the offset. So let's just type in $T for time by 5. Yeah, so it looks like it's working nicely. And you can just see this shape is much nicer as a source as opposed to this straight line. So just by using this shape with the Pyro sim, we'll get much more interesting results straight away. Let's create the source now. So drop down a Pyro source. And over here, we just want to initialize burn. So this will give us the burn and the temperature attributes. And another thing you can see here, we're losing quite a bit of the detail. So let's use a surface scatter. And this will just scatter points on the shapes that we have over here. Now you can see it's quite slow just to move between the frames. And we just have way too many points. It's like almost 2 million. So let's just lower the particle separation a bit. You can just lower it until you see it affecting the shape. So this is maybe a bit too much. This is much more reasonable. And you can just see moving between the frames. It's much faster as well. So now we can just drop down a volume rasterize. And let's connect it. And we want to rasterize the burn and the temperature. You can just see, first of all, the particle scale is way too big. We're actually losing all these shapes. So let's just lower it down. And use maybe 0.16. And let's also duplicate this. And we'll use this one for the velocity. I usually prefer to do the velocity separately, just so I can easily check it. So if we drop down a volume trail and drop down a scatter, so we can actually create points inside our volume, connect it, and connect it to the velocity volume here. And you can just see that everything is working properly, and we have proper velocities. So let's just merge these volumes together. And now we can just plug it into a Pyro solver. Let's start working on the Pyro solver now. So just highlight it, and I've actually let it calculate for a few frames, just so we see that everything is working. And you can see we're getting quite nice looking shapes straight away. But yeah, let's start making some adjustments. The first thing I've noticed is we're hitting the bounds of the sim. So if we just go to the bounds tab, and over in the padding, we can just give it something quite large, maybe like 10. And this just gives it much more room to actually expand and move about, and we won't need to worry about it hitting the edges. And another thing I want to change is just the start frame. You can see currently we're just calculating all these empty frames. So we can actually take the start frame from the pop sim. So just copy this parameter. And over here, just paste relative references. And now the sim will start at this frame. Now I'll just let it run for a few more frames so we actually see what's happening. Let's just go to the setup tab and give it a larger voxel size. So maybe 0.25 for now. And this is just so we can actually work faster. So straight away we can see we're getting like the velocities are just too high. Let's also switch to smooth shaded just to remove this bounding box. But yeah, you can see the velocities are really high and we're getting these kind of blobby mushroom shapes. So let's just go to the sourcing tab and change the velocity, like the incoming velocity, to 0.25. Another thing I can see here is just buoyancy. It's like barely rising. And it's fire and it's hot, so it should move a bit upwards. So let's just go to the shape tab. And let's just give it a buoyancy of 2.85. I also just want to, let's just create a camera to kind of frame the action, and so we can actually iterate it. So maybe something like this. Also, let's press D and go to the background and switch to a dark background. Maybe something like this. Now you just press Control and click on this camera, and it will create a camera in the view. Let's just create a flipbook. So just make sure to leave play bar at the last frame and remove this resolution. And let's hit start. Now let's just stop this and just set the start frame to be 1060. Yeah, and I can see here a few problems straight away. One of them is we actually need more substeps here, just because everything is like we have quite a strong velocities coming in, and everything is also moving quite fast. So you can see this kind of stepping we're getting. You get this kind of big blobs, and it's as if there's not enough information inside the sim. And another thing that's happening here, it's rising now a bit too much in my opinion, because I want it to stay kind of close to the ground. Let's just lower the reference temperature to 2000. And over at the setup tab, let's just give it some more substeps. So we'll give it a minimum of 2 and a maximum of 3. And yeah, I also want to bring in the collisions. So we want it to collide with the ground and also with the dragon head. So let's just drop down an object merge. And we'll select the VDB. And let's duplicate this and bring the VDB head 1 for the dragon. Now drop down a merge and connect these two together. And now we plug this into the collision section here. And just on the power solver, you just need to go to the collision tab and switch it to use SDF plus volume velocity. So let's run a new flipbook and see what we get. I've just stopped the sim, so we can actually compare the two different versions. And you can just see straight away, we're getting like all these stepping issues are kind of gone. Not completely, but it's much better than before. And it just fills up all this volume, and it actually also adds more detail inside the sim. You can see over here, we're now getting all this, and this is just by adding some more substeps. So the next thing we can do is just go to the shape tab and start adding some disturbance and turbulence and shredding, and just kind of work on the look of the sim and try to add more details. But I'll just show you what I kind of like doing in these situations. I kind of like using the shelf tool. If we just tap ground explosion, so we have this Pyro configure ground explosion. Let's just drop it in. And it just builds up this setup for like this kind of a preset ground explosion. But what we want to take from this is, let's just take this Pyro. This is a Pyro bake volume just for the look. And I also want to take this solver, because it just has in it all kinds of nice presets. You can also delete all this here. It's kind of already figured to give some nice looking results straight away. And we can just plug it in. And yeah, let's just get rid of all these keyframes. We don't need them. We know our time scale needs to be 0.75. Let's lower the voxel size to 0.2. The start frame, you can just, let's take it from here. So copy this parameter, set the start frame like this. As for the substeps, let's set it to be 2 and 3. And also on the shape tab, you see they have kind of these keyframes. Let's just delete them. And yeah, I'll just run a flipbook just to see what we're getting with this kind of with these settings. And I'll just pause the video and come back when it's done. Yeah, so I'll just stop the sim over here. You can already see there's a few things we want to adjust. But you can see it's already feeling much more explosive, and it billows out, and it just feels a bit more violent and massive in scale. And that's mostly because we have some flame expansion, and we also have some divergence that is helping it expand like this. But I actually want to just remove this. We also have the velocity here. Let's just switch it to add and lower it to 0.25 like we had before. As for the burn, let's just set it to 1. We don't have these trails, so we can remove this. And we also don't have a density. We have a burn field coming in. So let's just switch this to burn, and then we'll get some smoke, just a small amount that might add some nice details. As for the dissipation, we want something quite high because I don't really want any smoke here. And the temperature can also be quite high. We want it to kind of cool off quite fast and stop rising up. Yeah, and as for disturbance, you can see right now the block size is set to 0.2. Now if we go out and just create a box, and we'll just move it near the dragon head, just where the fire is located. You can see this is a size of 1, and currently it's set to 0.2. So this tiny dot is the disturbance size, and it's way too small, and we actually won't really see anything unless we have a really high resolution for the sim. So we can go for something a bit bigger, like maybe 0.4 or 0.5. So for now, let's just double it to be 0.4. Another thing we can see here is just we barely see any breakup. So let's give it a much higher disturbance. So let's set it to 75 for now. You can see this preset also gives us, like it actually turns on this speed field. And it set these kind of controls for this speed field that when it's moving slower, you get less disturbance. And we can adjust these values as well, but let's just leave it for now. As for the turbulence, I actually want it to be really low. Usually I use turbulence only for simulating kind of large swirls of air moving. So I tend to keep it quite low, maybe 0.1. And as for the swirl size, currently it's set to 15, which is really big. So it will give us these kind of movements. Maybe 4 would be a good value for the turbulence. So let's set the swirl size to be 4. And for the shredding, you can actually just give it a higher value as well. And let's just run another flipbook. I'll just stop the sim here. Starting to feel really nice. We get this kind of a rolling effect for the fire. I actually feel like I want this area to be a bit bigger as well. So we can just control this by the flame expansion. So maybe set it to double, like 1.5. And maybe lower the flame range to 0.5. And at this stage, I actually just want to see how it looks like with kind of a higher voxel size. So let's just set it to 15. And yeah, I'll just run a new flipbook. And the sim is still going, but you can see it's looking quite good. I really like all this rolling fire that we're getting here. And let me just stop the sim here. And another thing we can do is, if we want to see a bit more detail, you can just press D and go to the texture tab. And we have this limit resolution for the viewport. Depending on your graphics card, you can just remove this or set it to something a bit higher, maybe 500. And this will actually allow us to view higher resolution volumes in the viewport. So just to refresh the view, we can move one frame back. And you can just see everything looks a bit sharper. And you can just see the detail a bit better like this. Just before we cache this out, I want to make a few more small tweaks that I think we can get some more detail out of this. And there's a few things I've forgotten to adjust. So first of all, we can adjust the bounds. We used 10 before, so let's just switch it to 10. And also for the collisions, just switch it to SDA plus volume velocity, just so it will be using the VDBs here. Over in the fields, like what I see here is we kind of getting quite a lot of smoke, and I want it to be mainly fire, so just the emit from flame, let's lower it. And also let's lower the range a bit. To be something like that. This seems to be fine. And the buoyancy we used before is 285. So let's just set this. And in the disturbance, we can just maybe add a bit more roughness, just to make it a bit more chaotic. And also the speed range. You can just set it to be 0, maybe. Just so it will always affect some of the smoke, even if it's really slow. Because you can see it's kind of staying quite static at some points, like over here. It's barely moving, so we want to keep on affecting it. For the turbulence, we can also Give it a bit more roughness. And for the speed field, maybe make the range a bit larger. Because you can see it kind of affecting it here. You can see how it's kind of swirls it about. I feel like it's a bit too strong, so you can just make the range a bit larger, and that will help it. And for the shredding, you can see the block size, I haven't actually touched it, so let's just give it something a bit bigger. Like we're using a 0.4 over here, so just make it a bit bigger than the disturbance. And also let's give it a bit more roughness. And yeah, and also for the flame expansion, I kind of feel like this range is too high in a way. I want it to expand a bit more and just billow out a bit more. So let's just set this to be 1 and this maybe 0.35. And yeah, just another thing I wanted to adjust here is we can just change like the advection type here. If we switch it to BFECC, it's just a different type of calculation. And I kind of feel like it gives, in a way, a bit more details, and it just helps the simulation kind of roll on itself. And because it's fire, I also I want to add 2 more microsolvers, which will be vortex boost and gas vortex confinement. And what they do, again, they just affect the way the swirls work and the rolling motion. It's like a vortex boost. It just kind of finds vortexes and it just boosts their strength. So we'll just get some more rolling details. So to do this, let's just go inside the solver here. And we have this force output. And here we just need to use gas vortex boost. And we can add the gas vortex confinement. And if we just merge these together and connect them, they will be added to the sim. So for the vortex boost, we can just, you can see we can adjust the swirl size and the strength of it. But let's just leave it at the default. And for the confinement, let's set it to 1. And I'll just run 1 more sim before we cache it out, just to see these kind of changes. I've just stopped the sim here, so we can compare the 2 versions. You can see just doing these kind of small adjustments, I think the flame expansion really makes a big difference. You can see especially here, this one is much more explosive. And we also get some nicer detail here, just a bit more breakup on the shapes. And I think if we just play them together, this just feels much more larger scale and much more powerful. You can actually feel it kind of slowly moving along. Even here, just you can see all the detail inside the fire. Just feels much better. So let's start we can delete this old Pyro solver. And let's just call this one Dragonfire. Let's connect the file cache, switch it to be explicit, and switch the hip to job. And inside the geo folder, I just want to create another folder named shot01. So all of the caches for this shot will be in one folder. And I want this cache to be in its own folder as well. So we'll just do $OS. So this way we create a folder with this name. And then the file names will have this name plus the frame number and the BGO. So let's just change the name here to be cache Dragonfire 01. Let's just start caching this, and I just want to show you the difference between caching a sim like this as opposed to caching it as a VDB and just applying some optimizations to it. So let me just stop it here. And if I go to my geo folder, we have now a shot1 folder. We have this folder here. And let's just look at the, say, frame 1077. It's 57 megabytes. And if we look on the Pyro solver, we have this output tab. And it has this post-process options. And this is basically exactly the same as we have this node, Pyro post-process. So you can see it has the same settings. They just incorporated it into this Pyro solver. And yeah, we have this checkbox to convert it to a VDB. What this does, it takes all the empty voxels and kind of gets rid of them. You can also use a 16-bit float. This converts it down from 32 float. And again, like with no visual difference, you get much smaller file sizes. And another big offender is just the velocity volume, which can be quite heavy. So if we resample it down, you can save a lot of space like this. So we can do it by 2 times, but you can also do it by 4. And the only thing it affects here is the way it looks when rendering with motion blur. And with the tests I've done, it's barely noticeable. And over on the file cache, just change the ending here to VDB. So let's save it again. And just compare the file sizes. And you can see the same, these are the same frames. And now it's only like 2 megabytes as opposed to 58, which is quite crazy. So always use these settings when saving out your sims. Especially in a big project like this where we have a lot of smoke and fire. And if you're also happy with your sim, let's just go over to the solver here and just switch the voxel size to 0.1 and save it out like this. The sim has finished caching, and I've just added this null here, and I'm also viewing the sim through this Pyro bake volume. And yeah, this is just to get some nicer looking shading in the viewport. And another small change is I went to the voxel size and change it to 0.15. And that's just because I wanted the sim to finish faster. Just because I want to continue working. For next week, I will resim this at a value of 0.1. So we will get nicer looking flames and details in general. And I've also created this flipbook here, just so we can see how it turned out. And I'm quite happy with the result. It's looking quite powerful. And we're also getting some nice motion for the flames and all these kind of details. And of course it will look even better once we resim this. That's it for the dragonfire. If we go out now, let's just give this node a purple color. And this will represent our sims and setups. So I just hope you enjoyed this section, and I'll see you in the next video. Let's continue and start creating the setup for the ground fire. So for this, let's drop down a new geo, and we'll call it effects ground fire 01. And let's also give it a purple color. First of all, we need to create the source. And for this, we're gonna need the terrain and this dragonfire. So let's drop down an object merge. And let's bring in the dragonfire. And also let's bring in our terrain. So for the terrain, let's go to the collision terrain and bring in the geo. And now what we want to do is we want to transfer some information from this volume to this terrain. So to do this, we have a node called attribute from volume. And here we just give it the terrain and the volume. And let's just turn off the fire. And you can actually see where it's hitting the ground, we're getting this color. We want the flame. And it's currently set to a size of 3. We can set it to be 1, and that will be a float. And also in the input range, let's also just take the range down so we'll get like stronger colors. And you see we're getting this kind of leading edge according to the fire. But there are a few problems. Mainly we can see just the point counts are all over the place. We have different resolutions. So first of all, let's just fix this terrain and try to get a more consistent source. So let's, instead of the geo, let's bring in the VDB. And now we can just convert it back to polygons. And you can see this kind of brings everything back to the same resolution. And now we can just remove all this bottom part. So let's just drop down a clip. let's lower the distance a bit. Let's try -2. Yeah, and this can work. And now if we just drop down a scatter, and let's give it quite a few more points. You can just see the distribution now is even, and yeah, it's much better. So let's just remove this relaxed iteration and give it a lot more points. So let's start with this number. Seems to give a good coverage, and it also retains the detail. And yeah, if we have a look at the attribute from volume now, we can see it's working with the points. And we're actually getting a bit more detail as well. And what I want to do now is let's just delete all these black points. We don't need them. So drop down a blast. Set it to points, and let's type at CD smaller than 0.01. And now we're only left with these white points. Now in order to just paint this, this section, we can just use a Botnet and basically just emit particles wherever the white points appear. So let's just go inside. I'll just set the start frame to be 68 here. And inside the Botnet, if we just go to the emission type, we can set it to use all points. This way it just emits particles on each of the points. And we can also go over here to just remove overlapping and just set it to with existing, and then we won't get any overlapping points. And you can see we're getting this kind of a source being painted on. And of course, it's all being affected by the fire. What we can do now is just drop down a Pyro source. And for the fire, I just want to use a density. Now you can see we also get all these attributes from the Botnet. So let's just clean this before we move forward. We'll use an attribute delete. And let's just remove everything. We can also delete these groups, but it's not really, doesn't matter. Let's just press on this density. And currently everything is red just because the density is at 1. Now that we have these points and the source is kind of ready, let's start working on the Pyro solver. And yeah, let's try and get some nice looking flames, and then we can apply it to this source. So kind of like what we've done in the Dragonfire, I want to use one of the presets that comes with Houdini. So let's drop down a Pyro configure. And you can see Houdini comes with all these kind of presets. And I'm using this mostly just to save time. Let's drop down a bonfire preset. and see what we get. I'll just let it run for a bit. But you can see it just gives us this kind of a fire setup with all kinds of values dialed in that give kind of a good starting point. And yeah, it can save you time. You don't need to create everything completely from scratch each time. And if you just go in and make a few tweaks and changes, we can get something that looks really good. Let's just go over what we get here and see how they build it and make our changes. Now, if we just take a look at the setup here, all this stream here is just meant to add some embers. We don't really need it, so we can just delete everything here. And if we just take a quick look at what's happening here, you can see we have this tube as an emitter. And we have a Pyro source creating some attributes. And then we have these attribute noises, which basically just give some variation to the source. We have one of them for the density, one for the temperature, and one for the burn. Now, just to keep this setup simple, I kind of prefer just to use one attribute, which is going to be the density. So I'll just delete these two. And then we just use a volume rasterize to convert these points to a volume. If we take a look at the size of this compared to the source that we have, it's quite small. This voxel size is way too small, so I'll just switch it to something a bit bigger. And also for the Pyro solver, let's just switch to a voxel size of 0.1 for now. Let's also take just a section of this source. So maybe this amount. We want to work on a small size just so it will be faster and we can kind of dial in the look. And then we can create the sim for the whole sequence. So just for testing, let's drop down a time shift node. Just delete these channels. It will freeze the source in place. And we can use this one. So let's just connect this attribute noise. We can delete these two. And you can see here the noise is way too small. Let's just use maybe 1.5. And you can see we have this ramp here. You can just play around with it a bit. Maybe switch it to B-spline. And we can kind of make it a bit more contrasty, like this. We can also give it 0.75 for the roughness, just so it will be a bit more interesting. Now in the volume rasterize, let's just delete everything except for the density. Also, let's make sure that on the sourcing tab, you can see right now it's looking for a temperature field and a burn field. So let's just switch it to be density. And now we're getting the fire. So I'll just let it sim for a bit and we'll see what we're getting. The first thing I see here, we're getting smoke. And I actually want it to be a smokeless fire. So first of all, let's just delete these densities that are coming in. And if we run it again, we're still getting this black smoke. So if we go to the Fields tab, we have this density section. And this emit from flame basically creates smoke from the flame. So let's just turn it off. You can see now we're getting just fire with no smoke at all. So that's good. I'll just let it run and we'll see what we get. I've just created a new flipbook so we can actually see how the fire is behaving. And you can see currently it's just moving really slow and it feels really calm. And what I imagine for this fire is we want to create something that feels really big and chaotic, because it is being lit by dragon fire, which is, it's supposed to be something really hot and powerful. And we also have this big dragon here that's, it's just landing. So I would assume the wings will create strong winds and vortices as well. So let's start adjusting some of the values here and just try and improve this. So we can start by going to the setup tab. And let's just make the time scale a bit higher. So use 1.5, just so everything will move a bit faster. And for fast moving simulations, we also really should give a few more substeps. So let's just use 2. And you can see the speed that everything is moving up is quite slow. So let's just go to the shape tab. And we have the buoyancy here. And buoyancy basically just controls the strength and the speed that the fire is being pulled up. So let's use 1 for now and see how it feels. And you can also see we get this flame expansion and viscosity. Now, viscosity basically, it tells the flames to kind of stick together and create one big shape. So it can work for maybe smaller scale fire, maybe like a match or burning paper. But with this kind of a large and chaotic fire, I want these big licks of flame to break apart and give us all kinds of small detail. So let's turn the viscosity off. And we also want to turn off the flame expansion. Flame expansion is a way to help mostly smoke, but it can also affect the flames. And it kind of makes everything billow out as time progresses. Let's turn these two off. And you can see straight away everything is moving faster. We're also getting these nice breakups now, just by removing the viscosity and the flame expansion. So we're actually getting a bit more smaller details inside the flame. But what you can also see here is just the source. It's quite boring. I think if we play around with the noises a bit and just add a bit of animation and maybe inject some velocities, we can just break it up a bit and give it a more chaotic look. So let's just go over here to this noise and visualize the density. I'll also just create a camera so we can keep creating flipbooks from this view. Just uncheck this lock. Let's maybe add, let's give it a higher amplitude. And what I want to do now is, I kind of like these shapes, but I don't want them to change. I want to add animation on top of them. So if we just duplicate this noise, and let's just give it an amplitude of 1. And we can also remove this ramp. So I want this second noise to kind of affect these initial shapes. And we can add the animation on this one. If we just go to the animation, turn it on, let's just see what we're getting. And you can see it just makes it a bit more dynamic. Let's increase the pulse length to 0.3. And also let's make the element size smaller by half. You can see here we're kind of retaining these shapes, but just adding some animation on top of them. And we can also maybe let's just increase the amplitude a bit more. Yeah, this looks a bit better. Another thing to note is, because we increase the amplitude here, if we check the spreadsheet, you can see now we're getting densities in a range of 0 to 10. And I want to keep the densities in a range of 0 to 1. So to do this, we just we can just go to the post-process tab here. Let's just turn it on. You can see now we're getting densities, like our highest density is 1. Let's also duplicate it again, but this time let's use it on a velocity field. So even if we don't have a velocity attribute here, just by adding this attribute noise and specifying V, we'll get this V attribute, which is for velocity. Let's just set it to be a vector and select the operation to add. And we want it to be zero-centered. Let's also add some animation. This is quite chaotic and fast, but it might work. Let's use a pulse duration of 0.5. And also make the element size smaller. So maybe 0.5 as well. So this should be quite good. Let's rasterize this attribute. So just press V. And just drop down a merge. And merge these two volumes together. So we have density and velocity. Let's just go to our new camera here and just check that everything is working. Now I don't feel the velocity affecting it at all. You can see the density, like the new values give us more flames, which is good. But if we just go to the, we'll call it noise V, let's just increase the amplitude to 10 and just see if it's affecting it. And you can see straight away it's pushing the flames in different directions, so that's good. You can see just by making a few changes to the source, we're getting a much nicer result. It feels more chaotic, and we also get some more flames. And what I want to do now is let's add a bit more turbulence, like a large scale turbulence, just to simulate some wind. And we can also play around with maybe adding some shredding, just to kind of break up these shapes further. So let's just go to the Shape tab and turn on the shredding. And I know that the value of 15 worked for our Dragonfire, so kind of this kind of scene scale, this value is good. And let's maybe use a block size of 0.1, just because I want it to be kind of small. Like we want small details, and we want to break the existing flames to smaller shapes as well. And we can also compare it to the previous flipbook. And you can see the shredding, what it does, it kind of creates sharper looking flames, as opposed to, let's just stop it here. We go to frame 45. You can see the difference. It's like here it's a bit more blobby, or let's find a better frame. Maybe frame 29. Yeah, you can see all these shapes are basically kind of stretched and pulled apart. And yeah, just gives a bit more of a fiery look to it. Now I want to add another turbulence. Now we have this one here. So to add some more microsolvers, we just go inside the Pyro solver here. And if we just drop down a gas turbulence, we can add a second one here. Now I want the scale to be quite strong. And I also want the swirl size to be quite large as well. So maybe set it to 8 for now. Actually, it doesn't look like it's even affecting it. So just make sure. Yeah, you can see it's set by default to work on the density field. And we want it to work on the flame, because we don't have, flame. We actually don't have any smoke here, so it's better to directly affect the flames. And so let's give it a stronger scale, like maybe 2.5. And just see how it affects it. So you can see straight away, it's definitely pushing things about. If we just go out here and we have our box, so we can just maybe 12 will be a good value, because I kind of want these big rolling motions for the wind. So let's try a value of 12. We can also increase the post length, because we want it to be quite slow moving. Let me just create a new flipbook. And you can see this turbulence that we added really gives the feeling of some strong winds in the environment. And yeah, I think it's working really nicely. And I think in general the fire is almost done. There's only a few changes I want to make. So let's go back to the Pyro solver. The first thing is over in the Advanced tab. Let's just switch the advection to BFECC, like we did in the Dragonfire section. And also inside the Pyro solver, let's just drop down a gas vortex boost and a gas vortex confinement. And I'll just drop down a merge and connect these all together. And what the boost and the confinement will do is they will kind of tackle these long licks of flames and break them all apart. So it should give us nicer detail and just break up all these kind of big shapes. So let's give it quite high numbers, maybe give it a boost of 4. And for the confinement scale, let's use 10. And I'll just create a new flipbook with a new name, just so I can easily compare it to the previous version. I'll just let it run, and we'll be back once it's finished. I've just stopped the sim here. And you can see now that we've added the vortex boost and the confinement, it really breaks up the shapes and gives us a lot of high frequency detail. And I think also in the movement, it just feels much more natural now. And I'll just show you the previous version that we had. So you can actually see the difference. So I'll just go to the same frame. And you can see where we had these kind of big flames over here. We're still getting them, but everything is broken apart and we just get a lot more detail. So this is looking good. I actually forgot to do it before, but let's just bring in the collisions. So we'll drop down an object merge and let's just go to the collision terrain and bring in the VDB. and just plug it into the output for the collisions. And over in the Pyro solver, let's just go to the collision tab and switch the collision type to SDF. You can see we're getting a lot less fire. Because these points are on top of the ground, when we convert them to a volume, it means half of the size of the volume is inside the ground. So when we bring in the collision, the source is basically halved in size. So let's just go to the sourcing tab and maybe increase the flame amount to 1.5. And we can also go to the fields tab, and in the temperature, let's make it cool down a bit slower, so it will just linger for a bit longer. So I'll just run it again. And we're getting less flames than before. But anyway, I felt like it's kind of too big over here. Especially when we look at it through our camera and compare it to the dragon and the scene. But this is looking quite nice. I think we'll go with this. So what I want to do now is just disable this time shift and just run a simulation for the full duration of the shot. And let's just see how it behaves. Let me just stop the simulation now, because I can already see what's happening. You can see everything is working really nice. We're getting some nice movement on the flame, but it also feels quite uniform. So I would like to break up the shape. And I think we're also at the stage where we can just cache it out. So first of all, let's just go to the Pyro solver and to the output. And let's just check the convert to VDB, use 16-bit float, and also resample the volumes, like the velocity volume. And we'll do it by 4. You can see we actually don't get anything in the viewport now. I think it's because we turned it to a VDB. So let's see what's happening here. I think it has something to do with the density. Just go to the bindings here. And if we use for the smoke volume the flame, it'll actually show up. So yeah, let's convert it to VDB. Also just set up this Pyro bake volume. So also here we can go to the binding. Let's use a flame for the density. And we don't want any scatter. We want quite a low density value, so maybe 2. We don't want any color. And let's set the intensity scale on the fire to 50. And another thing I wanted to do is just to break up these shapes a bit more, like on a larger scale. So let's just view the density. Let's just duplicate this and kind of multiply it again with a larger element size. Let's just remove the animation. And maybe just use a ramp. It might be too much. I just want to create a few pockets and just reduce the incoming amount. It might be a bit too much even now, so let's try something like this. And also let's go back to our Dragonfire. I just want to grab this file cache. So I'll copy it. I'll paste it over here. We'll call this ground fire. Because we have this $OS set up, it will work properly. And yeah, let's just cache it. The sim has finished caching, and I've went ahead and created this flipbook just so we can see what we got. I really like the dynamic feeling this fire has. It's very chaotic, and we're also getting a lot of nice small details and breakups. I especially like this area here where we have this kind of big flame and the way it just breaks off into smaller flames. And yeah, just one more note for this section is I've simmed it at a voxel size of 0.1, and it took about 5 minutes on my computer. So obviously this is really fast, and we can resim it at a voxel scale of 0.05 perhaps. And this way we'll get nicer details, everything will look sharper, and we'll probably get also more of these smaller flames. For next week, I will resim this, and that way when we work on the rendering, we'll just get an even nicer looking sim. So I think this is all for the ground fire. I hope you enjoyed this section, and I'll see you in the next video. Just before you start caching out your fire, I found out there's a small problem with the setup here. So first of all, just because we're using only the flame, we actually don't need to export the temperature. So you can just tick it off and just save some disk space. And another thing, if you look over here, our density field is 0. Now this Pyro bake volume, it displays properly in the viewport. But if we go to the render view and just do a quick test render, you will actually see that it's not rendering. Basically, this Pyro bake volume needs a density field. So let's just fix this. We can actually take the flame volume and just rename it and replace this empty density. So to do this, let's drop down a blast. And first of all, let's just delete this empty density field. And I'll just duplicate this blast. And now let's just isolate the flame field. Now let's just rename it. So drop down a name. We'll call it density. And now let's just drop down a merge and connect these two together. And you can see now we have the density that's exactly like the flame field. So if I just connect it here and just do a quick render. You can see it's rendering properly. And it's looking good. So just do this small fix before you cache out your fire. And you'll be ready for next week. Just before we conclude this week and move on to the assignments, I want to quickly show you how to apply these setups that we've created on the different dragon heads. So it should be quite obvious, but just in case, what you need to do is just duplicate this setup here. And if we go inside, now what we need to do is just update all these settings and just apply them on a different head. So let's just hide everything and say I want this dragon head to breathe fire now. Let's just select 2 points inside of his mouth. So let's select this one and maybe this one. And let's select 2 points at the tip of his mouth. And now we have this emitter. And like we've done before, let's see when the dragon is starting to breathe fire. So perhaps on frame 78. So on the pop sim, let's update the start frame. And it will finish breathing fire perhaps on frame 100. So let's just go inside. And over here on the birth tab, let's update it to 100. We also got these keyframes, so let's shift them over. And let's just see that everything is working properly. You can actually see we're getting these strange collisions. Let's for now just lower the bounds and maybe disable the drag force. Of course, I'm doing this quite fast now just to show you the concept. Spend some time and make sure that everything is working properly and looks good. So this feels a bit more natural. And if we take a look at the pyrosim, we should be getting fire. So you can see it's a really easy and fast way to reapply this same setup just to a different head. And once you see everything is working properly and you're happy with the result, just recache it. And of course, make sure to change the name of the cache, because if not, it will overwrite your previous cache, which can be painful. So change the name of the cache. And once this is done, you can do exactly the same thing for the ground fire. So just duplicate it. And over here, just update it to use the second dragonfire. And over here, change the cache name. And yeah, and you can just press save to disk and everything will start calculating and saving out the files. So this is it for the effects for week 1. I hope you had fun, and I'll just see you in the assignment section.